Okay, guys. So we are going to um, talk today about um, arc length and areas of sectors. So just to talk about arc length, that's the arc. Like when I look at a circle, which is a bad-looking circle, but if I'm talking about arc length, what I'm talking about is the distance um, from point A to point B. Like how far did I travel from point A to point B, knowing a specific angle measure? That's what we're working on. What we're going to do is when we think about arc length, we're talking about distance, because that's what length deals with, is distance. And I know that circumference is going to have to be dealt with. So I know it's going to be circumference of a circle times the number of degrees traveled over 360 degrees, because that's how many degrees there are all the way around the circle. Or another way to think about this is 2 pi r times the degree over 360 is going to get me the length that I'm traveling. So I want to figure out from here to here, knowing that I traveled 270 degrees, how many yards did I travel? So what I'm going to do is I'm going to take the circumference, which is 2 pi r, and multiply it by 270 over a whole circle of 360. I'm not going all the way around the circle. I'm just going a portion, 270, which is like the same thing as like 0.75 of the way around the circle. So I'm going to take 2 pi times 19, and I get that to be 119.4 yards. And I'm going to multiply those two together. And what I get is 89.54 yards is the distance that I traveled. So when I talk about arc length, all I'm doing is taking the circumference of my circle and figuring out like what percentage of the whole circle did I travel. So I'm taking my circumference, in this case 2 pi times 11, and multiplying it by whatever decimal or percentage of the distance all the way around. So I'm going 240 degrees around a 360 degree circle. Okay? So when I take 240 divided by 360, that's the same thing as 0.66 repeating. So I'm going to multiply that by 2 pi times 11, which is 69.11 feet. So when I multiply those two together, I get the distance traveled to be 46.1 feet. I'm going to ask you to try the next few, but what I'm going to do is jump ahead and talk about one other concept with you, which is called the area of a sector. It's basically exactly the same thing as what we've been doing, but we're dealing with area. So I'm trying to figure out like how big of a piece of pie do I have in this portion of my circle. Okay? Like if I take 225 degrees of a whole piece of pie that's 8 miles in radius, what is that area of that pie? So when I think about this is going to be the same basic idea, but now we're taking the area, which is pi r squared, and multiplying it by the degree over 360. So it's the same basic thing as what we were doing before, but we're taking the area and multiplying it by the degree over 360. So I'm taking pi, I'm going to multiply it by 8 squared, and multiply it by my degree, which is 225 degrees, over 360 degrees. So I'm taking 64 pi, which is 201.06, and multiplying it by 225 over 360, which is 0.625. So when I take 201.06 times 0.625, I get it to be 125.67 miles squared. That's how big of a piece of pie I have. Okay? Looking at number 30, it's the same basic idea. I'm taking the area of my circle, which is 13 squared times pi, and multiplying it by 120 over 360. So I get 530.93 and multiply it by 1/3. And I get that piece of pie to be 176.98 feet squared. So I'm going to ask you to try the rest of these area of sectors and the arc length questions. We'll talk about those tomorrow.